guys. So thanks, man. Guys, we looked at slope intercept form a couple times so far this year. We're going to look at it again today. I'm just going to use it in a couple different ways. Tomorrow, we're going to do a short little lesson, like 2 examples with something similar to slope intercept form. And then during the second half of class tomorrow, like at 8:30, you'll start the test. All right? And then on Friday, you'll finish. All right? At the end of the lesson, guys, I'm going to explain a little bit more about the homework and reference sheet and stuff like that. All right? So we're going to look at writing equations in slope intercept. And we're going to look at doing it in 4 different ways. Can somebody remind me what slope intercept? We'll get to that in a second. Let's do this first. All right. So we're going to have you guys do it. We're going to have you guys do it in 4 different ways. All right. We're going to use slope intercept form to do 4 different things. All right. First thing we're going to do is we're going to give you the slope. We're going to give you the y-intercept, and then you're going to have to write the equation of the line. Like last week, we gave you the equation of the line, and you had to identify the slope and the y-intercept. We're just doing the opposite of this stuff. All right. Second thing we'll do is, just like last week, we gave you a graph, and you had to identify the slope. All right. With this, we're going to give you a graph. You have to write an equation in slope-intercept form. So we're going to have to identify what the slope is along with what the y-intercept is. Some of this stuff we've already talked about. Third way we'll do it. We'll give you 2 sets of points, and we'll ask you to put it in slope-intercept form. All right. And the last thing we'll do is we'll use a linear function like f of something equals 5. That's another way. That's another way we can write coordinates. We can put something like that in slope-intercept form too. All right. So just quick refresher, right? What is that equation for slope-intercept form? Who remembers? Donovan? Y equals mx plus b. We've talked about that quite a bit already this year. All right. So y equals mx plus b. All right. So you have the box on your notes, and then you have arrows coming off of the m and the b. Why do we have arrows coming off the m and the b? Why do we have arrows coming off the m and the b for? Donovan?
Because there's a slope and the y-intercept.
Okay, which one's the slope? M, and then the y-intercept is obviously b. All right. What was the little trick we used for slope so we knew what direction to go? Ellie?
Rise over run.
Rise over run. So on your notes in your box there, slope is going to be rise over run. If we ever, kind of like what we did at times last academic week, if we ever asked you just to find the slope, there's 2 ways you could do it. One way is obviously use this formula. All right, label your coordinates and you can plug it into that formula. What's another way you could do it that doesn't involve having to plug it into a formula? What's another way you could find slope without having to plug it into a formula? If we gave you a graph. Matt?
You could count the amount.
Yeah, if we give you a graph, I think your best bet is just to count. All right, and then if you can reduce. Like we already talked about, all right, the y-intercept, right, is b. As a coordinate, all right, if we give you a coordinate and the coordinate has a 0 in it, if the x value is a 0, then whatever the y value is your b, or your y-intercept. So we talk about doing it with 2 sets of points. All right, one of those sets of points we give you today is going to have a 0 in it. So that set of points with a 0 in it, the other number is your y-intercept. And again, we'll talk about that a little bit more as we get closer to that example. So again, this formula we've talked about before, rise over run we've talked about before, y-intercept, we've talked about all that stuff before. And those are the 4 ways we're going to do that. Okay? Everybody's good with this stuff? I can move on? Yes?
Yeah.
Yes.
Yeah. Okay, good, thanks.
Yes,
Cool.
sir.
So, I don't think I want that yet. Out of order here, Mr. Hager, I don't have it. The notes I sent you. Here we go. All right. All right. So the first way we talked about is we're going to give you the slope in the y-intercept. All right. So again, for all of these, obviously, so on your thing you have u's. You just want to write in y equals mx plus b. All right. Then on your notes it says plug in number given for. You have to write in slope for m. And then you have the parentheses. You want to make sure you attach an x. So like last week, we did something like this. And we asked you to identify the slope. The slope in this is 3. Last week, we didn't want you to put the x, because the x just told us what the slope was. This week, we're going to give you a number, and you're going to have to come up with this. We'll give you the slope in the y-intercept. You have to come up with this. So you have to make sure you put an x with whatever number we give you as the slope. It's the opposite of last week. All right? And then for your y-intercept, plug in number given for the y-intercept for b. So you're going to use this formula, plug in a number given for slope for m, put the x next to it. If it's positive, put plus, and then whatever number that we give you for the y-intercept. If it's negative, obviously put negative. Right? So those are the steps you're going to follow if we give you a slope and y-intercept. So first one, write an equation of each line with the given slope and y-intercept. So like it says, we want to use y equals mx plus b. Then we said plug in number given for slope for m. So what's the number it gives us for slope? Somebody tell me by raising their hand. What number does it give us for slope? Miguel? -3. Do I just put -3?
No.
What do I have to put with the dominant?
X.
X. Opposite of last week. Last week we asked you to identify it. You decided to give us the number. If we're asking you to write an equation with the given slope, you have to put the x with it. All right? What's the rest of my formula to finish it off? Chris?
-4.
-4. Y equals mx plus b. -3 was my slope. There's my m. Put x with it. My y-intercept, or my b, was -4. That's all for this. When we give you the slope and the y-intercept, that's all you have to do. Pull the things out, write it in the formula. Opposite of last week. Last week I identified the slope and the y-intercept. This week we're giving it to you. Put it in the slope-intercept form. This one has a slope of 0 and a y-intercept of -2. So what would my equation be? I know I'm using y equals mx plus b. I want to put these two pieces of information in y equals mx plus b form. What is my equation going to be? Yep, Nicole just said it. Y equals -2. I don't want to put y equals 0x minus 2. Because that x is still there. That's still telling me I have a slope of 1/1. If there's no slope, write nothing. Just like if we gave you one when there was no, if the y-intercept was 0, write nothing. You just write like y equals 2x. All right? So again, that's one way we'll take a look at it today. We'll give you the slope and y-intercept, plug it into the formula. That's it. Now, we're going to give you a graph. Just like last week, we gave you a graph and asked you to identify the slope. All right? This week, we're going to give you a graph and ask you to put it in slope-intercept form. So we know how to get the slope. We're just adding the piece of the y-intercept. All right? So again, we're going to use y equals mx plus b. For all these different ways we're going to do this, we're always going to use y equals mx plus b. All right? So the next thing in your note says, identify where a line crosses y-axis. This is the blank. Does anybody know what do we call where the line crosses the y-axis? Right, like Nicole just said, it's the y-intercept. Or in the formula, the y-intercept is what? We've already talked about this. B. All right, so identify where the line crosses the y-axis. This is, you guys have to fill in y-intercept or B. So you have to write this the last few things in that sentence. Next thing we want to do is, this goes back to last week. I want to count, right? I'm going to count from one coordinate to the next coordinate. And on your notes, it says positive slope. How do I know, what does a positive slope look like? What direction does it go?
Up to the right.
Up to the right. Right? We're always going to base slope off to going to the right. It goes up to the right. So if I wanted to count my slope, what would be the best way to go? Up, down, left, right. Where would I go first? Donovan?
Up.
Count up and then to the right. I'm going to start from the bottom point that it gives me, count up till I get to the grid line that my other coordinate's on, stop when I get there. That's my top number of my slope. Then I'll count over, all right? That's going to be the bottom number of my slope because it's rise over run. If I can reduce it, I'll reduce it. If I can't, I won't. So count. If it's we just talked about this. If it's a positive slope, I'm going to go up to the right. This is telling me what a positive slope looks like. It'll look like this. Up to the right. So to get my slope, I'm just going to count up till I get to the grid line that my other coordinate's on, and right till I get to it. Right? It's okay if it's a fraction. If that fraction is over 1, say if I got a slope of, I went up 3 and right 1, how would I write that as a slope? If it was 3 over 1. Would I put 3 over 1 in my formula? What would I put, Nicole? Just 3, right? Because any number over 1 is itself. And again, if you can reduce, reduce. All right? So positive slope, that's what it looks like. That's how we get it. You don't have to plug it in the y2 minus y1 over x2 minus x1. You don't have to do that. Just count. It's quicker. Because sometimes when you guys plug it in that formula, we might make mistakes. Let's not use that formula unless we absolutely have to. If you have a picture, let's just count. Negative. All right? Opposite of obviously the positive. It's going to go down to the right. We'll count down from the top point till we get to the grid line that the other coordinate's on, and then I'll just count over. Biggest thing I have to make sure I'm writing my slope is what do I have to put? If I have a negative slope, what do I have to make sure I have to put? Negative sign, right? That's why I always say for negative, count down. Hopefully that counting down will remind you that your slope is negative. All right? And remember, we're only going to apply the negative to the top number. All right? Don't put it in the middle. That'll kind of confuse you. Just put it right on the top. So we're only going to apply that negative to the top number. We always count down to the right, never down to the left. If I counted down to the left, look what happens. I end up getting a positive slope. I don't want that. It's negative. All right? So those are the steps. If we give you a graph, we ask you to put it in slope-intercept form. These are the steps you want to follow. All right? So you're going to do your y-intercept first when we do these. All right? So you guys have the graph on your thing, on your notes. It does give you the coordinates. You could do y2 minus y1 over x2 minus x1 to get your slope. But again, I think personally it's easier to just count. There will be some stuff we do later where you may have to do y2 minus y1 over x2 minus x1. Not for this, just count. It's quicker. All right? First thing I want to write involves no math at all. No counting, no math. Think about the formula that I'm putting in. What's the first thing? What's the first two things I should write based on the formula that I'm putting this in? Nicole? What's the first two things I should write? Think about the formula we're putting in. Gigi? Y equals. Always going to start with y equals because we want to put it in slope-intercept form. Now, based on my notes, all right? Bethany, what's the next thing I want to do? I I know that, but I have to find those things now, right? So my steps, I'm going to use y equals mx plus b. I agree. What's the first thing we want to find? So for the first bullet, we put use y equals mx plus b. The second bullet was what?
Identify where the line crosses the y-axis.
So at what point does this graph cross the y-axis?
0 and 2.
So what number is that on the y-axis? Is it 0 or is it 2?
0.
2. It's going to be 2. 0's the x, y is the 2. I want to use the y. And again, another way you can think of it as, again, whatever coordinate has the 0, the other number with it is your y-intercept. So where should my 2 go, Bethany? At the beginning of my problem, the end of my formula, where should it go? Did I just find the m or the b? I just found the y-intercept, right? So is the y-intercept the m or the b? At b. So I want to make sure I put it at the end. That's my b. Is it positive or negative, Bethany?
Positive.
Positive. There's my plus 2. So I just found my y-intercept. What's all that's left to find now? Slope. Donovan, how do I do it?
It's negative, so you go up and to the left.
You never go left.
Right.
Look what we wrote. You said it's negative, right?
Yeah.
How do we say to count if it's a negative slope? Look at your notes.
Down. And you'll still get the same thing if you.
You could do that. You could do that too. You could do that too. Yes. So you're saying go. What you say? Say what you said again. Go left, and then up.
Well, I said up and to the left.
Up and to the left. Okay. I'm gonna go down. I'm gonna go down and to the right because I don't want to make a mistake. I might screw that up. All right. So we'll go down. We're going down. 1, 2, 3. There's the grid line my other coordinates on, right? So 1, 2, 3. Actually, you know what? I'm just gonna put it here just in case. I'm gonna put this off to the side now, just in case I can simplify it. Anything else I should put with that 3? Jake? Anything else I should put with that 3 if I count it down? If I count down, what kind of a slope am I going to have? Not sure. If I count down, what kind of slope am I going to have, Nicole? Negative. Over. All right, let's see how many right I go. 1, 2, 3, 4. Over 4. Can I reduce that? No, right? If this was 6, maybe, yeah, I could divide by 2. I could divide by 3 in both. But again, I can't reduce that. So it's just going to be negative 3 over 4. What's the other thing I have to put? X. With the negative 3/4, right? G, good. Put it right in the middle so I know. There it is. Again, identify your y-intercept first. That comes at the end. Whatever numbers with 0, that's your y-intercept. There's a positive 2. Identify what kind of slope it is. All right, like Donovan told me, it's negative because it goes down to the right. All I did was count. Down 3, right 4, negative, make sure I put the x with it. All right? Here's another one. First 2 things I have to put, Chris. What's the first 2 things I have to write? Even before doing any type of math.
Y equals.
Y equals. Very good. Nathan, what's the first thing I want to find after that? So I know I'm going to use y equals mx plus b. We've already said that. After that, what do I want to find?
No, y-intercept.
Y-intercept. What is it?
3.
3. Beginning of my, right after the equal sign or at the end?
And
What am I going to write? Tell me.
plus 3.
Plus 3. Very good. Leave a space. Excellent. All right. Identify the slope. Say it again, Nicole. 0, right? I can't count anywhere. There's no rise over run. So you just got to remember, if it goes horizontal, it's 0. What if it goes vertical? What kind of a slope is that? Undefined. So my equation for this is going to be what? Y equals 3. That's a 0 slope. Good? So we looked at 2 ways so far. We give you the slope and y-intercept. plug it into the formula. We give you a graph. Identify the slope, identify the y-intercept, put it in y equals mx plus b. Let's look at the third way. Now, we're going to give you two sets of points. Just like we had here. There's two sets of points. The only difference what we do now is going to be, there's going to be no picture. There'll be no graph. It'll just be two coordinates. All right? So, again, same deal like we've done with every single type of problem we've done so far today. Y equals mx plus b. Now, we talked about this a little bit in the other one. Look at the number with 0, 2. Look where it went. Look at the number with 0, 3. Look where it went. There was no x attached, right? So based on those two problems that we've done so far, the number in the coordinate with 0 is going to be the what in our formula? The y-intercept, right? So we just answered that. We just answered that question. Whatever the other number is in the coordinate that has 0, whatever that other number is, that's going to be your y-intercept or your b. We're always going to give you two sets of coordinates, and one of those coordinates is always going to have a 0. That's what we're doing right now. You're always going to have a 0 as in one of the coordinates. All right? So again, no counting, no identifying where it crosses the y-axis. See which coordinate has 0. The other number goes at the end of your equation for your y-intercept. Now, this one, we don't have a picture. So we have to use this formula. So on your notes, you have a little blank. You want to write in y2 minus y1 over x2 minus x1. Because before, we had a picture. We could just count. Now we don't have a picture, so we have to use this. All right? And that's going to give us our slope or our m. This a little added piece here where is you have to use the formula to find slope. So this is one difference. No picture. You have a picture, you can count. You don't have a picture now, you've got to use this formula. All right? I'll leave that there so you guys can still kind of see it. All right, so this one. And remember, guys, I don't know if you want to write this. You may just know x1, y1, x2, y2. You don't have to write that if you don't want to. Again, if you know how to label them, that's fine. If you're still not sure from what we did last week, you may want to write that down. So if I'm going to that's how you label. All right, so in this equation, that -3, based on how I showed you guys how to label things, that -3 is going to be the what? x1, y1, x2, y2. It's going to be x1. That's going to make 5.
X1.
No.
Y1.
y1. What's this one going to be?
X6.
x2. You can do it vice versa as long as you're consistent. You can call this x2, y2. You can call that y1, x1, y1. You just can't do like, this can't be x1 and this be y2. You just got to be consistent with what you do. All right? Or if you just want to draw, like Mr. Hager was doing last week, he drew a line from this to this. He drew a line from that to that. Just to show you how to match it up. All right? Me personally, I liked how Mr. Hager drew the lines last week. Because that way you're not doing like this, when you plug it in your formula, you're not like doing the second one first and mixing things around. I like to do it just like this. Match these two guys up, match these two guys up. All right? I'm going to draw my line. I'm going to put my 2 minus signs because those are part of the formula. On the top, again, I'm just going to do y1 minus y2. Again, I know my y's go on the top, x's go on the bottom. So I'm just going to go from the first y to the second y. 5, the minus is part of the formula, -1. Like we talked about last academic week, you may have 2 negatives in a row. It might happen. So if I'm going y1 to y2 on the top, what's going to be on the bottom? Ellie?
Would it be -3 minus 0?
Yes, it would. All right, on the bottom, -3 minus 0. Before I go ahead and solve this, is there anything there I should do first? Anything there I should change?
I make the plus.
Yeah, make the double negative a positive. On the top, what am I going to get? 6. On the bottom, -3 minus 0, -3. Always check to see if I can I simplify? Can I simplify that? Ready?
Oh, wait, never mind.
You good?
No,
Can you simplify that?
I mean, I guess.
What does this mean? 6, what does that line mean? Besides being a fraction. 6, what operation? 6 divided by -3. You know what it is? Not a half. If it was 3 on the top, 6 on the bottom, yes. But 6 is on the top.
I don't know.
What's 6 divided by 3? 2. Now I got a negative divided by a positive. What do I get? Negative. What did I just solve for? That 2 is going to be my what? Slope, right? Slope is what letter again? What letter represents it? M. M equals -2. It's going to leave that there for now. We're going to need it in a second. Now I'm actually going to set up my equation. What 2 things do I start with? Always? Y equals, very good. Y equals, all right? Do I have the first thing that I need in the formula? X is mx, right? Our m we just solved for is what? -2. That's it? That's -2? X. Again, I just want you guys to remember that if we're having you set up the formula, all right, having you write an equation in slope-intercept form, you have to put an x with the slope. You have to. You can't just put the number. You have to put the x with it. All right, what's the last thing we have to find? Y-intercept, our b, right? So based on what we wrote on our notes, how are we going to find that? Matt, based on what we wrote in the notes, right? So we're looking at, on the back side, given 2 sets of points, we know we're going to use y equals mx plus b. That second bullet, the number in the...
Coordinate with the 0 is the 1.
So which coordinate has 0, the first one or the second one?
The second one.
So Matt just told me my second coordinate has the 0. The other number is the y-intercept. What's the other number, Matt? -1. That's how simple it is. Identify what coordinate has the 0, and that number with the 0 is your y-intercept. Here you go. That's your equation. Given two points, that's your equation of a line in slope-intercept form. All right? That'll go through both of these points. -5, -3, 5, and 0, 1. Yeah, one example for that, right? Sorry, I'm going to skip this one just for the sake of time. You okay with that? But I'll just do it real quick. We're not going to do the whole thing. Can someone just tell me, based on what we just talked about, what's the y-intercept in those 2 sets of points? Gigi? -5, right? The coordinate that has a negative, has a 0, the other number is going to be your y-intercept. Y equals, again, I'm not going to do the slope.
That's a special case.
It'll be a special case anyways. Okay. Do you want to do it? Meaning it's 0 for slope.
Yes.
Yeah. So guys, if we go back and go through this, you're going to end up getting 0 for a slope. So kind of like the picture we had of the slope of 0, it'll just be like y equals -5. So the biggest thing I want you to take away is if you get a slope of 0, don't put anything for it. You're only gonna have an equation that has a y-intercept. So whenever you have a slope of 0, you only have the y-intercept in your equation. Good, done with that. Again, I don't know why this is out of order. We already talked about this. Yeah, okay. So we got these couple examples. So we've done given slope and y-intercept. We've done given a graph. We've done given two sets of points. Now I want to talk about using a linear function. And we'll do a quick little word problem after that, and we'll be done. All right? So again, same deal. We're going to put it in y equals mx plus b, just like everything else that we've done today. So, we're going to be in it's going to be like in function notation now. So we have like the f of something. Whatever number is inside the parentheses, so all we're doing here is we're just writing coordinates in a different way. So we're doing we're going to give you two sets of points that is going to be written in a different way. Right? They're going to be written in function notation as opposed to in the coordinate notation. Just two nice points. Whatever number is in the parentheses, that's your x-coordinate. All right? Whatever number comes after the equal sign is your y-coordinate. So you can still make two sets of coordinates out of it. Remember, we've said that f of whatever means the same as y equals. F of 2, f of x, f of whatever, it means the same as y equals. So we're saying, that's why we say the number after the sign is the y-coordinate. Y equals whatever the number is. So the number inside, if we give it in function notation, what's inside the parentheses, that's your x-coordinate. What's outside is your y-coordinate. All right? And the number that comes after, for one of the function notations, we're going to give you f of 0. Whatever number comes after the f of 0 is your y-intercept, because that's going to mean the same. Let's say if we gave you f of 0 equals -2. Here's my x, 0. Here's my y, -2. Here's my x, here's my y. Just like we talked about. The coordinate that has the 0, the other number is your y-intercept. Right? Because it's 0 on the y-axis, down -2. That's where the graph would go through the y-axis. So again, this is just a different way to write coordinates. That's all. Same as we did last time. All right, we'll label the x and y's. Right, x1, y1, x2, y2. Use the slope formula to find slope or m. So this is very similar to when we give you two sets of coordinates. The only difference is they're going to be written in function notation as opposed to coordinate notation. But we can take when we do this example, we can take them and put them in coordinate notation. Right? They look like what we just did. And we'll do that. And then we'll label them and do exactly what we just did. So write a linear function f of the values f of 0 equals 10 and f of 6 equals 34. So we get f of 0 equals 10 and we got f of 6 equals 34. So let's take this f of 0 equals 10, and let's make that a coordinate. Let's take it out of function notation and put it in the coordinate notation. So what would this coordinate be? What, comma, what? This first one. This function, if I want to put it as a coordinate, it would be what, comma what? 0, comma 10. Like we talked about when we did the notes. The number inside the parentheses is my x. The number that it equals is my y. All right, so it would be 0, comma 10. How about that second one? All right, Ryan. It's in function notation. Make it a coordinate. What, comma what? 6, comma 34. What's inside the parentheses is the x. What's outside, or what it equals, is the y. Label them. You don't have to label them if you don't want them. I'm going to connect them. I'm going to go this to this. I'm going to go this to this. These are my x's. These are my y's. What do I have to do now? Why did I draw those lines? Why did I connect those things? What am I finding now? Yusuf?
Because you're finding your x1 and your x2.
That's why I just connected them so I didn't have to label them.
Exactly, yeah.
Okay.
That's what I'm saying.
So I'm going to draw my line, right? So I'm going to use that slope formula now, right?
Yeah.
What operation is in that slope formula?
Division.
Division. And what else? Before division, we have what? Subtraction. Subtraction on the bottom, on the top. Subtraction on the bottom. What two numbers? And don't worry about doing y1 or x1. I mean, don't worry about doing y2, x2. Again, that's why I connected these. We'll do this one first, this one second, this one first, this one second. What goes on the top? The x's or the y's? The y's, right? Because the y's are your rise. It's rise over one, run. The rise is your y-axis. Y's on the top, x's on the bottom. What two numbers am I going to put on the top? Yusuf?
34 minus 10.
34 minus 10. Or 10 minus 34. Doesn't matter. You could do it either way. But this is when it's important. You've got to be consistent. So Yusuf went from here to here. This y to this y. So if he did it that way, on the bottom, what do you have to have? Yusuf? 6 minus 0. Over here, it would be 0 minus 6. You couldn't do 6 minus 0. That wouldn't be consistent. However way you do it, just make sure you're consistent. All right? I'm going to do it Yusuf's way because I'm not going to end up and have to deal with any negatives. So 34 minus 10. What do I get when I do that, guys? 24. 6 minus 0. 6. Simplify it. 4. Good, Nicole. What did I just solve for? What letter? What letter did I just solve for to plug into my m? Good, my slope. So m equals 4. Now I'm going to set it up in slope-intercept form. What do I start with? Y equals. I have everything I need now, right? After that y equals is going to be what, Dylan? So what's the formula? Y equals mx plus b. So when you look up there, do you see m anywhere? So what am I going to write after the equal sign? 4. Anything else? 4x, right? When we find the slope, we want to make sure we put the x with it. What's the last thing I want to write to finish off my equation? Miguel? Which is going to be? 10, right? How did you know that, Miguel?
Because on the first coordinate is the 0.
Yeah. Like Miguel said, we know, and guys, when we do these, we're always going to give you a coordinate with 0. Right? There'll be no tricks with this stuff. There's always going to be one coordinate and the other that's going to have 0. Again, look at the coordinate. It has 0. The other number is your y-intercept.
So the number next to 0.
The number, you can think of it that way too, Yusuf. The number next to 0. The number to the right of 0. Right? The coordinate that has 0. The number to the right of it is going to be your y-intercept. Right? And that's how you do that. Mr. You want to take a look at this word problem? I'll bring you in. Yeah. All right.
take a look at the, is that the last one, I think?
Yeah, there's a couple, there's a couple blanks they gotta fill in.
All right. So the last problem is going to involve a word problem. But usually when you have a word problem, in order to figure it out, you've got to come up with an equation first. And that's the kind of equation we're going to come up with, called a linear model. So what that means is we're going to come up with an equation that models or represents some kind of situation. And our situation can be represented by a straight line. Not everything in real life you can use a line to represent, but our problem is going to be nice and simple. Okay, so straight, it's going to be like a straight line equation. And what's the equation, what's the form we've been using all class?
Oh,
Y equals mx plus b. So that's the kind of linear model that we want to come up with. All right, so we're going to take the information that's in the word problem, and we're going to come up with two coordinates.
So guys, you can just write where it says the goal is, just put create two coordinates.
Because if you can take and pull two coordinates of information out of the word problem, then it's going to be exactly like the problems you've been doing all class. Right? We just got to figure out what are the two coordinates. So you're going to kind of look for numbers in the word problem. You're probably going to see 4 numbers. 2 of those numbers are going to be x values, 2 are going to be y values. We just got to kind of figure it out. Okay, and that's what I just said. Once you have the coordinates, finding the equation is like what
So
you
guys,
just
where it
did.
says then, just put in y equals mx plus b. Where it says then on your notes, that last bullet, just put in y equals mx plus b.
And when you put it in y equals mx plus b, what does that involve finding? What 2 things?
Slope and y.
Slope and y-intercept.
Yep, that's what I was.
And guys, chances are when we do this, it's going to be a coordinate that's going to have a 0 with it. That's how you're going to be able to find your y-intercept.
All right, anyone still copying that part now? Nope. All right, so let's take a look. And you guys already have this printed on your notes, so you're good. It says, all right, excluding hydropower, U.S. power plants used renewable energy resources to generate 105 million megawatt hours of electricity. That's a lot. It said that was in 2007. It says by 2012, they had generated 219 million megawatt hours. Right? So I'm seeing some numbers here, like this 105, 219. Then I got a couple years in there. Those numbers are probably going to be important. So it says write a linear model. So remember, linear means this. We got to figure out a slope and an intercept based on those numbers. So write a linear model that represents the number of megawatt hours generated by non-hydropower renewable energy. Right? And it's going to be as a function of years since 2007. Right? So let's see if we can figure out what our 2 coordinates would be. Let's start in 2007. Do we know how much electricity was generated in 2007 using, what do they say, renewable resources? How much electricity was generated in 2007?
Not how many hours.
Well, yeah, how much electricity measured in megawatt hours? Yeah. How much? 105. So in 2007, 105 megawatt hours of electricity were created. That's how your electric bill is. Well, hopefully yours isn't in megawatt hours. It's either kilowatt hours. It's a little smaller, but same idea. Now, what year was that in?
2007.
2007. How many years away from 2007 is 2007?
0.
0.
That's where you start.
So when we look at years since 2007, you look at your year, you look at what it says, and you figure out how far away it is. So Mr. Roy said there'd be one with a 0, and there you go. Now, do we have any other piece of information there besides how much electricity was generated in 2007? Yep.
We have how many electricity was generated in 2012.
Okay, we have how much electricity was generated in 2012. How much electricity was generated in 2012 using non-renewable resources? Yep.
219 million.
219 million megawatt hours.
And that would be 5 years after?
Yep. So years since 2007. 8, 9, 10, 11, 12. Right. Now, I'm just going to put in parentheses next to these 105 and 219. It wasn't really 105. It was 105 million. So we're just going to keep in mind this is in
Okay,
millions.
when we solve for our slope, we're not gonna put like 105 with a bunch of zeros, we're just gonna put the 105.
Because otherwise, yeah, I'd have to put comma, 0, 0, 0, comma, 0, 0, 0. Right? But that's just easier to write. Okay. Any questions where the 105 and the 219 came from, or the 0 and the 5? Right. So now let's just turn these into coordinates. How would you write the first row as a coordinate?
0.
0, comma,
105.
105. And then how would you write the second row as a coordinate?
5, 219.
5, comma, 219. Now you've got two coordinates. It's just like a problem like this. You just match up your coordinates and find the two things you need. What's the first thing we need to find?
Year 1.
Okay, we could find the y-intercept first. So I need something here, and then I need something here. Which one of those is the y-intercept?
The first box or the second box?
Second.
The second box. What's the y-intercept?
First box or the second box?
Well, we know, I think you said it was the second box, right? So we got that. Now what goes in the second box? Yeah, 105. All right, so that's the easy one. There's no calculation. What's the first box again? What's it? It's slope. And can somebody tell me my calculation here to find the slope? Now, if you think of it like that. Yep.
5 times 219.
Well, this formula, it's got subtraction in it, right?
Oh, so 5
Yeah.
minus 219?
So remember, what goes in the top? The y's. When she said 5 and 219, one of those is an x, one of them is a y, so we kind of mixed them up.
Mr.
Yep,
You could do 219 minus 1.
yep, that's how I would do it. 219 minus 105. So I'm just going to kind of put an arrow the way Yusef did it. He did 219, wrong one. He did 219 minus 105. So we got to do it in the same order here. What would go in the bottom?
500.
5 minus the 0. Okay, so let's simplify that. What do we get in the bottom? We get 5. All right, and in the top, let's see, we're going to get, what's 19 minus 5? 14. So 209 minus 105 is 114. And what's that again? 114 over 5? It's my m, which is my slope, which goes right in the first box. So now we've just created a linear model that represents the amount of renewable electricity used. So we just have to figure out your two coordinates.
Guys, the thing I'm handing out, don't put it away just yet, 'cause I want to explain it to you.
Yeah, so Mr. Roy's got a few reminders he's going to go through. Yes?
I have the meeting at 9:30, so should I wait or?
Right when the bell rings, if you go, you'll be
But
okay.
it's like 9:15 when it goes.
No, we get out at like 9:13.
All the tests are all.
Alright, so guys, like I said, leave this sheet up as I'm handing it out.
Oh, bro.
That's what you like.
So, Ms. Hager and I talked, we pretty much covered everything that we need to cover for this week when we looked at this week's test. So only a few things we have to cover tomorrow. So, tomorrow's test will be in class. It will not be a take-home. Right? Tomorrow's test is going to be in class. You will still get a take-home, but the take-home test will be when we get back from vacation. So you will still get a take-home, it just won't be this week. All right? So we'll do a short little lesson tomorrow for the first half of class, start the test during the second half, all right, and then finish on Fridays. We do have class on Friday. So you guys have the test review. All right? The reference sheet, very important that you listen. It's posted on Google Classroom. All right, it'll be posted by 10 o'clock. It's optional. You do not have to do it. Just understand, you cannot use the test review. You cannot use this. All right? If you use the reference sheet, it's up to you. If you want to fill out a couple examples on it, that's fine. You want to fill out the chart for doing transformations, that's fine.
Mr. Ware, what reference sheet is it? What sections?
3.7 to 4.2.
And it's, okay, the test review 3.7 and 4.1?
Yes.
Okay.
There's no 4.2 stuff. Now guys, very important. You have to print off the reference sheet because there's a couple boxes on there we're going to fill out in class tomorrow. There's 2 examples on the reference sheet from 4.2 which we haven't done yet. We're doing that tomorrow. So at some point between now and tomorrow's class, you need to make sure you print off the reference sheet because you'll need it for what we do tomorrow. If you don't have it, you won't have those examples for tomorrow for the test on your reference sheet. Now, my suggestion is, as you're going through this, if you look, the first one says C 3.7 review chart. If you look at that and you can't do it without looking at your notes, go back to that section of notes, fill in that chart on the reference sheet. If you look at on the back, like number 9, C 4.1 example A. If you can't do that without looking at your notes, you may want to fill that box in on your reference sheet. But again, this is the homework. It's not a package deal this week. You only have to do this tonight to get credit. You have to decide what's important to you to put on your reference sheet. Just make sure you print it off for tomorrow so you can get those 2 examples. Remember, we still have class on Friday. We'll finish the test. Progress reports on Friday. That's it. So make sure you, at some point today, print off the reference sheet.